Question 6a then, explain what is meant by the term isomerism. So this is one of those key terms that you just need to go away and learn. So for this one, obviously it's 2 marks. You need to say something along the lines of molecules with the same molecular formula. Sorry, let me bullet point this again. So molecules with the same molecular formula but different, oh goodness me, but different structural formula. That's really what we wanted. Let me go through the things in the mark scheme though. So instead of molecules in the first bit here, you could say compounds, and you could say substances, and you could say hydrocarbons. You could not say elements or atoms. Where you've said molecular formula, now they've underlined molecular, so it is very important to say that. Or you could have said the same number of each type of atom. That was also allowed because it sort of means the same thing. Now, if you've said rather than molecular formula, you've said general formula or empirical formula, then you can only get 1 mark. Okay, so it is key that it is the molecular formula. The second mark then comes from different structural formula. Now that also allowed, I'm going to write this one down for you, displayed formula. If you said it's got a different displayed formula, or just a different structure is allowed. But if you said something like, it's the empirical formula, the same empirical formula but different displayed formula, you obviously can only get 1 mark because you said empirical rather than molecular formula for the first point. So be really careful about that. Okay, 6b. The displayed formula of heptane is C7H16, and it looks like this. Which one of the displayed formulae below does not represent an isomer of heptane? Put a cross in the box to indicate your answer. So to do this question, what I would do is I would add up the number of carbon atoms and the number of hydrogen atoms and see which ones have the same molecular formula as heptane. So let's just go through them one by one. The first one has 1, 2, 3, 4, 5, 6, 7 carbons. Good. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it is C7H16. So I would say that that is an isomer of heptane. Look at the next one then. So we have got 1, 2, 3, 4, 5, 6, 7 carbon atoms. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 hydrogen atoms. I would say that that's an isomer of heptane. C then has got 1, 2, 3, 4, 5, 6, 7 carbon atoms, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 hydrogen atoms. That is also an isomer of heptane. And D then, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh dear. That also looks like an isomer of heptane, doesn't it? However, it isn't. And this is where you need to be careful. So it does have, don't know why I wrote that out, it does have the same molecular formula, but it doesn't have a different structural formula. So remember that around bonds you have what we call free rotation. So what I could do is, let's just count the longest carbon chain in this one. 1, 2, 3, 4, 5, 6, 7. It is the same as heptane. All I've done is I've twisted it slightly so it looks like it's at a right angle. It is exactly the same. So D is the answer because it doesn't have a different structural formula. It's just been twisted so that it looks bent, whereas actually it isn't.